defeat the zombies. Welcome, Ernesto. So it's a pleasure to be here and to tell the truth. I learned a lot with Adrian's presentation and with all the other presentations as well. Now we're going to speak about zombies. If someone can be impressed, there are some scenes that are a bit impressive, so please let me warn you. Now, what are zombies? These are people who are the living dead, and the only goal that they have is to eat brains and meat, and the only thing they do is being a threat to our world. We're living in a world of the walking dead, so we have to survive as much as we can in that world. Now, let us go back to the real world. Now, zombies. How many of us have had to maintain a zombie in our life? Raise your hands. 10 people had the bad luck of having to look after a zombie. Well, zombies are everywhere. Our world is full of zombies, and if you never had the chance of looking after a zombie, then you are very lucky. I'm so glad for you. But there will come a day where you will have to look after a zombie, a project that is dead, nobody wants to touch, but still exists, is still alive, and still plays a role, which we don't really know what that is. My name is Ernesto Tagberger. I'm co-founder of Ombu Labs, and with Ombu Labs, we built a Ombu shop, which is an online shop to sell in Latin America. And we also built minimum viable products for other startups. We also maintain zombies. And we look after these zombies, which is the minimally viable products that end up being projects that are very difficult to maintain. And I'm going to be the first person to state that maintainability is not sexy. At this conference, someone spoke about maintainability because this is not something that sells. It's not something like Node.js, like Clojure, like Scala. These are not cool technologies. But most of all, this is a set of concepts that we have to know about when we want to write software so that the psychopath that Volker was mentioning doesn't come to fetch us at home. And why is this important? Because if the project is successful, then more than 80% of the life of that project will be about maintainability, about adding features, about correcting bugs. And what we want to do is to have a simple code, maintainable code, and to have quality. But what is quality? Quality is a very important concept, but also very complicated. The simplest definition is that something meets its objectives. So this definition was made by a troll because it only kicks the issue of quality over to the requirements. So the issue of the requirement is a giant issue that has to do with requirement engineering. So I never came across a project that complies with all the requirements that have been defined 100%. Requirements can be response time, functionality, usability. And to tell the truth, I don't like this definition at all. The definition I like is the definition of ISO 9126. Well, maybe you're all asleep already. ISO 9126. I understand that maybe will put many of you to sleep, but this is very good. And this has 6 points. A component, a product, or a web application should contain all these, so it could be considered a quality product. Now let us take a look at each of these points. Functionality. The component we have has to meet the function with which it was conceived. It has to solve the problem it was created for. So each of those points has 5 or 6 sub-elements. I won't tie you with this, but I will tell you in general terms what this is about. well, then you can think about this and see how many of your widgets or libraries really meet this. Then we have reliability. So if any of the components or widgets of my product freezes and then recovers, then our product has to continue working. It has to have a certain failure tolerance. The third point is usability. We give the product to the user, and the user doesn't have to read a 3,000-page long manual to know how to read it. They have to look at the interface, and this should be user-friendly. They have to be able to use it without us having to sit down next to the user and explain how every single thing works. Then efficiency. A product or a component or widget doesn't take 3 hours to find a solution when this can be done in 3 seconds, that not all the memory of the server is occupied or the full disk is not occupied. So it has to be friendly with the environment. And then maintainability. So the concept of quality includes maintainability. And something important has to do with this. If a product is maintained constantly, does this mean this is a quality product? Well, not necessarily. There are some components, like Adrian mentioned, LS and Unix tools that haven't been maintained for many, many years. Now, are they quality elements? Yes, they are. So we can prepare all this list and we can see that they respond to the issue of maintainability. Now, maintainability means that we can add a functionality in an easy way. We can analyze it, find the cause of an error, of a bug, in very few minutes or in a day, but not in 2 weeks. And then portability. We can take this component, this widget, and take it from one environment to another without this being a nuisance. Now, what is important to build maintainable software?
Going back to technology, I won't discuss technology, but rather concepts. Paradigms in programming. Sometimes we are so interested in technology, in Ruby, Node.js, or whatever, that we don't stop and think what paradigm of programming is being used in this framework with this technology. For instance, we won't come with the object-oriented paradigm and try to create something for Node.js. Probably we end up creating a zombie because we want to create a paradigm that is not compatible with this technology. Object-oriented technology. Sometimes we don't consider concepts such as object, unique responsibility terms, contract designs. We end up with huge classes, and then we have to divide them into services, as Mike said earlier. And maybe we leap to code, and we don't stop for a second to put together the data model, the object model of our application. The design patterns. A very good book is The Gang of Four. How many of you know it? Well, more than half. Good. If you haven't read it, I recommend it because it's good to learn of the design patterns, because maybe you don't apply them, but with the tools that you use, probably you are applying it. And the design patterns give us, as programmers, give us a common language that we use with other developers, and we can use sustainable code because we look at a library and we can detect the patterns, and we can assume what the developer was thinking of. For me, and I think that for many of you, it's not dead. I won't dwell on it any longer, but it's dead for certain complex problems, and when trying to solve them using tests to see what can come into and go out of our methods. Maybe if we don't do TDI, it's good to write the code first and then to write the tests. But it's really good to write tests of integration. One of the most important parts for me to write maintainable codes is to have experience. And really, it's not something that I can explain today in 30 minutes. But it's good for you to come to experiences like this, to listen to people that know and have already run into problems so that we can learn from their lessons and their teachings. And maybe it's good to participate in open source projects to see what's being done and what the experienced people are doing, and based on that, to develop software that may follow that trend. So I don't want to bore you with definitions. Let's see a real problem. What happens tomorrow? Your boss comes and says, well, I have this project, you have to maintain it. Or a new client says, I have this project, and the developer that was working at it cannot work at it any longer. I need you to maintain it. The most probable thing is some developer developed it and says, well, I won't maintain this code. It's quite a frequent situation. So he adopted poor decisions that generated a technical debt that created an environment that made it difficult to write the tests. So having fewer tests, we end up with a project that's difficult to maintain, or directly we end up with no tests at all, and the tests will be by hand. That's how it finished being a project. That maybe the developer doesn't want to maintain it any longer. But the client says, no, but the code has quality. Okay, maybe for him it does, because maybe it has a function. Maybe the client says, no, it has quality because I'm getting $1,000 a week, so it's doing the things that I need. It's my business, and I'm receiving revenues because of this. So for the client, it has quality because it meets a function. As you see, the issue of quality is rather relative when we are talking to a customer, to a client. So what are the alternatives that we have? Well, the first one is to say, let's kill this zombie. Let's do it again. I'm a very good developer, and I'm going to do it maintainable, and you won't end up with a zombie. And the client says, no, I already paid for this project a lot of money, and I want to maintain it. So if you are not willing to maintain it, I'll talk to somebody else. So that's a dilemma. Should we maintain it or not? Maybe, but not maintaining it, we are saving a lot of problems. But the objective of the talk, I'm going to say that we're going to maintain it. And for a few weeks, we can blame the other developer. We can say, well, this bug was already here. The developer this is. This is something that works, really, to blame the other developer. So after 2, 3, 4 weeks, well, after 1 month, that's it. You are responsible for all those horrible decisions that the developer had taken. And very probably at 2 a.m. they'll call you to say that the application is not working, and then you turn into a zombie trying to maintain the project. But there is an alternative. Here, Rick can live with a zombie, and this is possible. All of us want to kill the zombie and create it again because we love to create things. We are developers. But sometimes we can't kill the zombie, so we have to start healing it. My suggestion is first to create integration tests. Very probably the project doesn't have a single test. So we can start with a very simple test. We start to describe a certain home page. When I get in a certain page, it should not explode, and that we could do that with several pages. probably will start with those with which the client is making money. So I prefer to have a project with this test than without any test. Another good thing is to set up a continuous integration. Some services will run the tests automatically for every pull request that I do. Some with a pull request. So we started some with Travis CI, Soco CI, TDDIUM, and CodeShip, or also with continuous integration. We are using TDDIUM, and it's good because for each pull request, they run all the suite, and we see whether anything is broken or not. And usually, when you are maintaining a zombie, you see that if you touch something in a complicated class, everything will break. Another tool that is good to is Flog. And here I'm in charge. I'm responsible for this. I developed a zombie, so and at the time it was an ugly zombie, and we see this complexity of all the code, and we had to start fixing it because those were decisions that I made, starting with a minimal viable product, and I said, well, here we can pivot this way or that way, and gradually that created some technical debt, and we can see it in the complexity of Flog. Flog gives a score to each of your files based on the complexity of the files that cannot be grouped with classes. It's very good to give you an idea of what are the most important zombies within that zombie. This is a library that we use and we see that it's a little bit simple. Usually they say that if a method or if a file is over 60, you should refactor it. But that's up to you. I won't give you such a simplistic recipe. Another service that is good is CodeLiner. That is a paid service for private projects, and it's free of charge for open source. And it's good because it gives a score to each of the classes in your library. As one of the speakers said Foca said this morning, don't take it so seriously. It's not that it's a project that needs to have an A in each of the classes, but it's good to see the code smells of each of the code smells of each of the classes. In Churn, for instance, you can see the number of times that the file is changing in the Git repository, and we can also see the complexity by methods and the different code smells that detect code climate. It's all automated based on rules and language. And another recommendation is to divide and conquer. What happened to us with AmbuShop, it's that finally it turned into a giant Rails application. And the Rails application had different projects within the same application in Sinatra and in Rails that made it very difficult to maintain. Whenever we run our integration tests, it took more than 10 minutes, and that was not good at all when you had to touch something in admin, and it would run all of the tests for routing of stores and all that. So what we did was to separate AmbuShop into small projects, some in Rails, some in Sinatra. To tell you the truth, I don't want to start a discussion here. I'm aware that anybody can create a zombie in Sinatra and Rails or Cuba if you don't have a clear idea of what I just said. It's a problem of concepts and theory. So AmbuShop is divided into sub-projects. So whenever we touch one part of jobs or API, then only the tests related to those codes are run. And it's good to group the code into different components.
Another point we had was the CSS. This ended up being something very difficult to maintain in giant files, and the solution that we found is the one of bad frost. This was mentioned some time ago, and it is good to have a component system for CSS. And this is not only for CSS, it also applies to other parts of the code. It is good to have these conventions, these design patterns, in order to generate code that can be maintained. So what we have is the utilities, the grid system, the peerfix, and the reset. So this is the foundation of the CSS of Bamboo Shop. Then in the Quarks part, we have all the basic elements, the paragraphs, the links, the dips, the tables. Then in the data part, in the atoms part, we have Quarks components, we have the error button, and it is interesting how the code is mounted layer by layer. And to tell the truth, this module with components has interesting alternatives. So the interesting thing is to divide the CSS in layers, in codes, and you build one on top of the other. So tomorrow, when you have to touch something on one of the pages, then you go to the molecules and you touch the footer or the navbar, which is in the molecules. And then each of the sections is a file contained in the app assets, etc. And then we have the pages, because obviously we have to apply certain rules to certain pages. So we define the style sheets for the pages, for example, for marketing, for partners, for jobs and quotes, etc. If you take home something from this presentation, I hope this is on the concepts, on the design of program paradigms. This is not an issue of technology in the sense of creating products and components that are maintainable. Technology is there. It is the implementation of our concepts. If we are clear about the concepts, we can create better products and better components. If we follow the conventions of the design conventions in CSS, etc., the programmers that come after us will be much happier if they continue with the project. And that is what we want to have. We want to generate code that is maintainable, and then tomorrow a psychopath does not come and kill us when we are sleeping. So I recommend these links. Some are books. I encourage you to read this. Thank you very much.